Hi, everyone. So it was pointed out that after the last video that I just did summarizing the SkyPortal paper very briefly, it might be nice to do a short video going through the paper itself to guide folks if they are going to give it a read to at least the aspects that I consider maybe particularly interesting, or where to find certain pieces, because it is a long paper, and you can see in the see up here something like 22 pages, and so many of those are references, but it's not a short paper, it turns out. And so I'm going to take a pass through the paper to and some of it will be a little bit of a repeat since the last time, but hopefully it's still of interest to folks. Right, so the paper was titled "The Data Science Platform to Enable Time Domain Astronomy." It's written by a variety of folks. I sort of led the charge, but with Josh and Guy at Berkeley, and Sarah, who's at Observatoire de Côte d'Azur, and Theo, who had worked with her and is these days at Caltech, amidst a wide variety of, let's say, contributors that we've had to the code base, Stefan, Ari, Tama, Dima, Danny, Brian, Viraj, Shada, Young, Leo. These are all folks who really, either currently or in the past contributed directly to the software. And then, we had a large stack of what I'll call contributors slash users, like folks who work on the app and have made it better through feedback or through documentation, everything like that. And then a long list of the students, Carla all the way through film, who worked on the app either through internships or RUs and that kind of thing. And so it's I'm pretty proud that it's a sizable group of people who have really made all of this possible, and clearly based on the on the institution list, it's not a small number of institutions and folks who come together to work on this. Kind of talk at the end, but it's clearly an international international collaboration, and that's something we're particularly proud of. Kind of moving along. So the abstract is pretty normal, and we covered a bit of that in the last video. But I'll just sort of highlight the key pieces, at least to me, of the paper and where to look. So in the introduction, we talk about kind of the current needs for multi-messenger astronomy, the heritage that, let's say, SkyPortal in the shape or in the form that it exists today was built out of. Coming from a multi-messenger background, I've been particularly interested in, what are the technical interfaces we can use to make, make follow-up observations of, gravitational wave detections, neutrino detections, GRBs and that kind of thing with facilities like ZTF or Rubin. And so this, this sort of code base wasn't built in a vacuum. There are a variety of collaborations that were, let's say, put together, even back from 01, but kind of looking ahead to 03, the growth crowd led out of Caltech, Monty Kosiwal as PI. Leo Singer and I had built this growth target of opportunity Marshall to use ETF to do follow-up during 03. The Grandma folks, led by Sarah Antier in this case, had built their own platform, and we came together to make kind of a single one-stop shop to do a lot of the multi-messenger science we wanted to do within SkyPortal. So SkyPortal, when we arrived at the project, wasn't particularly multi-messenger focused, and so a lot of those features were built over the last couple of years with taking great insights from the growth, TO Marshall and iCare and so on. And so this is kind of the introduction, talks about at least, some of the history of that. So in section 2, we kind of we talk through where at least our perspective is in terms of the kind of where the software ecosystem for time domain astronomy sits right now. We point to some other really great applications. For example, the TOM toolkit that the LCO folks have built, Astrocolibri, which is becoming a popular, let's say, online interface to a variety of public data sets. Easy Peasy, which Dave Coulter, currently at Santa Cruz, built. Yeah, so there's a variety of sort of these either data visualization or kind of TOM-like systems to do follow-up and interfaces and such. And so we, definitely point to some other folks who are doing similar, really excellent work. But then section 2 kind of talks through basically this figure, which I talked through in the first video, talking through the ecosystem at large, right? We have our optical surveys, ETF and Rubin, and kind of the multi-messenger instruments that, let's say, feed them triggers, LIGO, Virgo, Kagra doing gravitation waves, IceCube doing neutrinos, and then, Swift and Fermi doing GRBs. And then we have this whole layer of brokers, most of which are designed as to take in the Rubin alert stream, but are practicing, let's say, or live on survey data like CTF or Atlas right now, doing machine learning classification, annotation, filtering of those very large alert streams and sending that information out to the community. A variety of very popular platforms. There's, in some sense, kind of the spirit is similar with the fact that there's the TOM and the Easy Peasy and Astrocolibri, right? They all serve in SkyPortal, right? They serve various aspects of kind of this community, and the brokers work in a kind of a similar way. Then for the multi-messenger instruments, right, we have GCN and SIMA that take in multi-messenger let's say triggers and then redistribute them to the community. And this is kind of where SkyPortal sits. It takes in information from brokers and from GCN in this case, and puts them together to be able to do things like trigger follow-up on interesting objects that perhaps are in some kind of gravitation wave localization to fit them to a kilonova or GRB or supernova model, and then get email or phone alerts for the the most interesting objects to wake up in the middle of the night to do that multi-messenger astronomy. And so section 2 really walks through at least my or our small perspective on where a application like SkyPortal kind of sits within this very broad ecosystem of software that exists these days. Right, and so then section 3 is kind of nuts and bolts. We start talking about SkyPortal. First, we go through some of the alert brokering, which we just mentioned, right? So brokers are really designed to take these alert streams and then, filter them, annotate them, add complementary information that allows you to decide, is this particular object of interest to me scientifically or not? And so we talk pretty extensively about Kowalski, which was really built by Dima Duev in-house at Caltech. He's at Weights and Biases these days, and nowadays our team, especially Theo, kind of leads the further development of it, let's say. But we talk about how Kowalski, which is based on this Mongo-based system to do the filtering, and these days it has a not small footprint, let's say, of the amount of data stored. We're up to something like 38 terabytes over 3 deployments. We have 3 different versions of Kowalski deployed on site at Caltech, and it covers just a ton of data at this point. Then we talk a little bit about AMPL, right? So we've mentioned a number of different alert systems, Think, Alerce, and the like. But ample, which is kind of stored at DAISY, they provide many of the filters that we use in-house at ZTF. And so we talk a little bit about the way Ample does its alert filtering. And then finally, we talk about Think, which is a French-led at EGC Lab in Orsay, a French-led broker that the Grandma crowd in particular interact closely with and use within their version of the app. And so we have a section on that. So we go through and talk about some of the brokers, some of the differences, but the truth is there's an entire another paper to be written comparing and contrasting the various brokering sort of let's say styles and code bases and everything. Hopefully someone else should do that down the line. Right. So then we go through and talk about some of the associated software packages. So, SkyPortal itself is a not small code base, but it builds on the shoulders of, many open source software packages, both Python and JavaScript based. But here we highlight a couple of them. One is base layer, which takes care of a lot of, let's say, the quote unquote base of the app, right? So it does like user management and sets kind of the way that we take care of schema, and then interacting between the front end of the back end, and kind of takes care of all of that stuff. And then the second we highlight is HeelPix Alchemy, which is a software package built by Leo Singer at Goddard, who made this really nice Postgres-based interaction with HeelPix, which is a way to essentially tile the sky, and it's highly efficient, and we rely on it to do all of our spatial queries at this point. Right, and so then we talk through, let's say maybe I'll highlight this briefly, the multi-order coverage type sky maps. And so it's this HeelPix sampling that we use to look at probability maps. So this is some kind of localization, and you can break it down into HeelPix tiles, and then use ZTF, for example, to cover those localizations. And we use HeelPix Alchemy to take care of the vast majority of that. Right, so then we talk about a number of features, and we kind of break down the what I'll call the features into two broad sets. One that has to do with point sources, and one that has to do with kind of multi-messenger capabilities. And so we talk a little bit about the way we create filters and do scanning within the app. And we highlight the ways that we sort of display photometry and spectroscopy, and try to make those calculations as reasonably efficient as possible in the app. How to create finding charts and star lists, right? If I have an observing run at some telescope and I want to make a finding chart so I know where to point my spectrograph, this is all done inside the app. We talk a little bit about some of the other features that exist. We can produce periodograms within the app that are computed actually on the user side. We have a pretty comprehensive classification and taxonomy sort of framework, whereby folks can even vote on what they think the classification is for a particular object. And then, of course, we have direct interaction to be able to trigger telescopes like LCO or LT or SEDM, or in the future something like Winner or ZTF, to trigger follow-up of sources. And so that's all done within the app. Right, so that's kind of the overall what are called point source features, and then we do something similar for the non-point source and multi-messenger features. We talk a little bit about the the way that we receive information from GCN. We're quite, we're directly integrated into the kind of the GCN Kafka format and use that. And a lot of the work that we've been building is, to efficiently interact with these events. So for example, we can do observation planning. Folks within the team worked a lot on this software called GWEMopt for, 02 and 03 era, and will be used again for 04, where you take a sky map, you take some kind of telescope, and you can get observation plans out. And so we have, and similarly, if you have a sky map and some observations, you can display that, display those on the app. And so here's a example of taking the taking some kind of sky map in the galaxies inside in this case, but you can do something similar for displaying the sources inside your localization, or the observations. You can do all sorts of things on that page. We also have integrated with this software called SimSurvey, and Sky Survey is kind of the next generation version of it, built by Mikhail Rigaud, where you can take transient supernovae, kilonovae, GRBs, simulate them within the sky maps, and with either the observation plans that you've produced or actually the observations that you've taken, ask questions like what fraction of GRB afterglows above some absolute magnitude would I have detected, things like that. And so that's all built inside of the interface. And so yeah, here's an example of taking a set of ZTF fields in this case, and looking at what fields are observable and when, and creating observation plans and everything like that. Similarly, you can do the same thing for galaxy catalogs. This is valuable because gravitation wave localizations, gravitation wave detectors are only sensitive to, a few hundreds of square degrees. And so it's very popular to use galaxy catalogs to dictate follow-up. This is one way in which it's done. And so this is, we have kind of natural synergies with, being able to ingest popular galaxy catalogs and use those to do cross matches or to do scheduling and things like that. Okay, so then we have, so we had kind of our individual sources, we kind of had our extended sources, and here we kind of have the other category. We're calling interpretation and coordination features, but it's really kind of the other category. So here we talk about shifts. And so the concept here is that it's very common within these larger collaborations to assign folks to be on duty, and hopefully in their sort of working time zones. And so we have almost a Google Calendar like setup within the app, so folks can sign up for shifts and tell each other when they're going to be scanning or triggering the telescope, things like that. In addition to a pretty comprehensive notification framework, things as simple as if I have a source classification like a superluminous supernova, and I absolutely need a phone call when that happens, when someone tags a thing as a superluminous supernova, you can get a phone call. Probably more popular if I have, a new gravitational wave event, get a phone call, email, WhatsApp message, and it's all configurable, and you can, filter on whatever kind of stream that you like, which is very valuable. The other key piece of infrastructure that's really taken off lately is refers to as the analysis framework. And this kind of came out of the need. It's very popular to want to do things like do Bayesian inference or provide some kind of chi-squared fitting, amongst other things, on light curves or spectra. And so we've really built out this analysis framework whereby you can either trigger sort of different light curve fitters, MOSFET and MMA. Ample has kind of their own in-house thing that they're working on to trigger within the app to extract physics right within the web server, which has a lot of value because, again, some of that computing is abstracted away a little bit and just kind of taken care of for you. The other thing that's kind of also started to take off really recently, kind of inspired by all the stuff that's going on with ChatGPT, is we can now use, OpenAI to try to provide narrative summaries of the sources and the information that they have. And so we view this as a valuable thing for, if I have a bunch of interesting objects in the localization, these are the kind of summaries we'd really like to have for all of those objects to, for example, put into some kind of GCN. And so we see there's, as this being like a lot of future here and in this area, and we expect it's going to continue growing with things like being able to do searches for give me all objects within some kind of particular galaxy or something that looks like a kilonova, whatever. So, doing searches that way is pretty exciting. So finally, we give some examples of course, we've used the system to trigger on, many handfuls of GRBs at this point. We'll be doing something similar very soon for the gravitational waves, and we expect that this will be the usage of the app in this way is only going to continue to grow. We should give a quick example here where we show the number of sources that we end up querying within a given, in this case, GRB sky localizations, to kind of get a sense of the number of sources we have out there. You can see as sky area grows, and some of these examples, you get a lot of sources, which is pretty scary for 04, but we'll see how that goes. Yeah, and so then we come to our conclusion, and the part that I'll kind of highlight here is we talk a little bit about what it's been like to integrate, for example, students and interns within this really production software project, right? It is that it's scientific software doing production software, but we have had many students contributing at all sorts of levels in this. And so we talk a little bit about the experience bringing students into the project and some of the benefits and some of the challenges that it's faced. Similarly with regards to how to balance the fact that our team is inherently international, multiple collaborations, everything like that. Finally, we also kind of acknowledge some of the things, let's say, we've learned a little bit about interacting with our users. It's very important to, in any project like this, to have very, regular interactions with your user base, which in its own way also can create some tensions in addition to the benefits. And so talk a little bit about that. So yeah, I hope that this was kind of a interesting but brief oversight into the paper. We hope that you read it. As I said, it just went up on the archive a few days ago, so send us feedback, and we are really looking forward to hearing from the community about what they think. Okay, till next time.